Hello everyone, welcome back. In our last tutorial, we have seen how to use a pre-built data set, how to download a pre-built data sets into Pytorch. We have used MNIST data sets in our last tutorial, and we have checked how to download and how to load the data sets into the memory and how to visualize those data sets. In this tutorial, we're going to see how to use the data sets and how to feed those data sets into the into our simple neural network. And then we are also going to see how to train that neural network using this data set. We will also check how to test that neural network which is trained properly or not. So let's go and build a simple neural network in Pytorch. So this is our code which we have taken from the last tutorial. So until this point, the data sets is downloaded. If it's already downloaded, it will be taken from the local drive, and then it will be loaded into the memory, into the train set and test sets. And now we're going to build a simple neural network to train the data sets. So as I've said in our last tutorial, that this data sets consist of images and labels. The images contain the handwritten numbers. Then the label contains the numbers respective to those images. So we are going the neural network which we're going to build is going to identify what number is written on the image. So let's go and build it. It is very simple. We are going to use the simple Pytorch neural network, and we're going to build some simple layers. Let's see. So for that, I'm going to import the torch.neural network. And I'm gonna also import the torch.neural network functionals. And let's build a simple class. Let's have a simple class to build a neural network. I'm gonna say it as dnet, and I'm gonna inherit the Pytorch neural network model. And I'm gonna go to the constructor in it. Self. I'm going to initialize this superclass, which is the Pytorch neural network module. Super parenthesis dot to call its constructor. So the superclass of NN module got initialized by this point, and we are going to build the first layer of our neural network. So here we are overriding the default neural network module. Here you can just say the how many number of parameters which you wanted for your neural network. That like how many layers, how many nodes, and what kind of inputs, what kind of outputs, what kind of like optimizer, and the activation functions which you're going to use in the neural network. Everything will be defined here, and rest of the things rest of the things are taken care of by Pytorch neural network superclass. So that's why we are inheriting the Pytorch neural network module here. So you can see it like building the neural network is very easy if you're using this Pytorch neural network, if you're inheriting from Pytorch neural network. So we're going to build our first fully connected layer. let me say self.fc1 since it's a fully connected. So I'm going to say nn.linear as 28 cross 28. Since our input image size is 28 by 28, we are going to pass that as an input to our neural network. So this side is input and this side is output of that layer. So the output is going to be 64. So this is the input layer and this is the hidden layer, which comes with the 64 nodes. So I'm connecting all these 28 by 28 nodes into 64 nodes. So that will form the first layer, fully connected first layer. So I'm going to create the same. Sorry, I'm going to add the one more fully connected layer, fully connected hidden layer, 64 by 64. I'm going to say that layer as FC2. We can have one more hidden layer, and this one would be 3. And then the third layer, the fourth layer is going to be the output layer. Self.fc4 is nn.linear (64 by 10). Since the numbers of our labels, since our the numbers are between 0 to 1, that's what we are going to classify. So which contains 10 digits. So that's why the output is going to be 10. So here we have defined the number of layers that we're gonna have in our neural network, and we have also declared how many number of parameters each layer is gonna have is also defined here. So this is a simple neural network which comes with one input layer, one output layer, and 2 hidden layers. So we have to connect all these layers one by one. So for that we are going to define the in order to define that, we are going to use, or we are going to override the forward function of the NN module. X is going to be the input, and here I'm going to connect the I'm going to pass the input to the first layer, fully connected layer, X. And I'm going to assign that to a variable. So this is, so now the input is connected to the now the input of neurons are connected to the first layer, and then that layer's output is going to be assigned to X. So this X can be assigned to the next layer, so that it will get connected to the next layer. Self.fc2 X. So again I'm gonna assign it to one more variable, which can be the same variable, since this is not going to be used later on. So we just keep assigning to the same variable, and then in the same way you can do it with FC3 and FC4 as well. So what we are doing is, here we have connected all the layers. One layer's input, one layer's output goes to the next layer's input by just this is the X is the actual input, which is an image, and then that is connected with the first layer, first fully connected layer, and then that first layer's output will be fed into the second fully connected layer's input, and then the second fully layer's output will be fed back into the fully connected layer, third fully connected layer. So that's the way it goes on and on. You can also create a simple, one line nested function, but that looks more unreadable. So this is more easier. So what we have done is, so we have connected all the layers, and we are just getting the output here. So we are gonna say return X. Here we have not done one thing. The layers are connected, but we haven't defined any activation function here. So activation functions are very important in the neural network. So we need to assign the activation function. What kind of activation function which each neuron is going to use should be declared here. For that, we need that functional module. So here we are going to use the ReLU activation function, where ReLU is the most popular one. So we're going to use that activation function here in all the layers. I'm just assigning directly to one layer, which means each layers. Excuse me, but actually the activation functions would be applied in each neuron. In each neuron parameter calculation. So here we are just assigning it to the entire layer, but in real time it will be applied in each and every neurons. So the ReLU operation will be performed in each and every neurons. So here for the output, we don't need the activation function. Instead of activation function, we have to calculate the softmax function. Since we don't need anything to be activated in the output layer, we just need to find the the softmax, find the maximum probability of the output. So for that, we need to apply the log softmax function on the output layer, and with the dimension of 1, since 1 contains the output. And then here we are getting the output of our neural network. We are returning in the forward pass. So this completes the definition of our neural network. So here we have declared the number of layers, and here we have connected the layers one by one. We have also declared the activation functions and the output function as well. So we have defined our neural network. Now we will check. Now we're gonna instantiate the neural network class which we have created. So I'm gonna say deepnet as the object of our class. So I'm gonna instantiate the neural network which you have created, and I'm gonna print the neural network instance to see what kind of layers it's built inside. So there you go. You can see there are 4 linear layers. Comes with a 784 input layer, which is 784 nothing but 28 by 28 image size, and the output layer is 10. I mean, like output layer having the nodes, or I mean like nodes 10. So this is the neural network which we built, and let's see how to pass the data which we have loaded into our memory. Let's try to pass a simple example input data before passing the actual input data from the original data set. That I'm gonna say 28 by 28. And I'm gonna pass this to our neural network deepnet X, and I wanted to see the output, so I'm just assigning it to the output variable. I wanted to print the output and see what's going on there. So here if I run it, so it's throwing error, tensor is not defined. Oh sorry, it's not tensor, it's torch. Everything starts with T, makes me more confused. Okay, so here it says a different error. So this is a size mismatch, 28 by 28, and then the input is the actual input is 784 by 64. So here we have to change the size. Actually, we have to change the shape of the input tensor. So for that, we need to say view. View 28 into 28, because we are flattening our two-dimensional array, XY array, to one dimension. Then we have to process, because since because the input layer is linear, which is like which will expect the flattened flattened input. It won't accept the two-dimensional input, it will accept only the one-dimensional input. So what we are doing here is like we are just flattening by just taking the the consecutive rows and placing it into the same array, and then we are just flattening it into one 784 one-dimensional 784 size array, rather than passing the 28 by 28 two-dimensional array. I hope that helps. I think we need to give the -1 here. If you don't give the -1, then it shows some error. I think it's related to shape. So it's one-dimensional, but still we have to pass the dimension. Here you can pass the the dimension by saying 1. It will accept that. If you don't know the dimension properly, then if it is a 5-dimension or 6-dimension, you can just simply say -1. It will calculate the shape accordingly based on the input you're feeding. So this is the output which we are getting from our deepnet. So it is taking the input, if you pass it in this way, and giving us the output in this output tensor. So all works fine, but we are just passing the random value here. So now we're gonna see how to pass the data set values into the neural network, and then we'll also see how to train the neural network.